In many cases, the code in a try suite will be capable of throwing more than one type of exception. In such a case, you need to write an except clause for each type of exception that you want to handle. And in the examples that we have seen, that we have to handle a specific type of errors or exceptions by specifying the error type, like value error, division by zero error. But sometimes you might want to write a try except statement that simply catches any exception that is raised in the try suite, and regardless of the exception's type. So we respond the same way. And we can accomplish that in a try except statement by writing one except clause that does not specify a particular type of exception. Let's take a look at the example. This is the same example that asks for user's input, perform division, and then there are more things that's added to this code is to open a file to read and then close the file. So the exceptions that might happen in this whole block of code can be value error, which is from this conversion, or can be IO error, which can be from opening this file. So any file IOs can possibly cause an IO error. So these two specific errors are listed here to be handled. And if an exception occurs in this try suite, the Python interpreter examines each of the except clauses from top to bottom. And in the try except statement, when it finds an except clause that specifies a type that matches the type of exception that occurred, it branches to that except clause. So that is to say, if a value error happens around here, the logic will go here to handle the value error. Or if there's no error until a file open causes an IO error, and the Python interpreter will go to the except clause, branches to the except clause where an IO error is handled here. But if none of the except clauses specifies a type that matches the exception, so if something random happened around here that's not specified by these two specific exception or error types, and then the interpreter will branch to this last except here, which will handle any types of error. So basically, it's a general error that gets handled. Notice that when you list all the possible errors, you want to list all the specific error first, and always put the general error handling code at the end. If you put this to the top or move this to the top of the error list, what will happen is any error, any type of error will be handled by this except. Because when you go through all the except from top to bottom, you hit this except at the top and you will just execute that handler there and skip the rest of the code. So make sure you put the general error handling code always at the end of the exception list. When the exception is thrown, an object known as an exception object is created in memory. The exception object usually contains a default error message pertaining to the exception. So it is actually the same error message that we have seen displayed at the end of a traceback when the exception goes unhandled. When you write an except clause, you can optionally assign the exception object to a variable. So it looks like this: except type of error as error. So this is the exception object. You use a variable err to refer to it. But this is basically just a variable name. You can have your own name that you wish. And after doing this, in the exception handler, you can pass the err variable to the print function to display the default error message that Python provides for that type of error. So the same example as the previous example, except that I added this as error here, and then I can print this error. So that the error message you have seen is the default message that's provided by the Python. So this is the exception object that we can use directly in our exception handling code. And there's another statement you can add to the try except, which is an optional else clause, which appears after all the except clauses. And the block of statements that appears after the else clause is known as the else suite. The statements in the else suite are executed after the statements in the try suite only if no exceptions were raised. If an exception is raised, the else suite is skipped. So the same example, I added the else suite here, okay, which does the formatting for the number. Notice that this else is only executed if you executed all these lines of statements with no error. So after executing the entire try suite, there's no exception raised, and you jump to else. The try except statement may have an optional finally clause as well, which must appear after all the except clauses. And the general format is finally : statements. It's at the end of all the try except suites. The block of statements that appear after the finally clause is known as the finally suite. The statements in the finally suite are always executed after the try suite has executed and after any exception handlers have executed. The statements in the finally suite execute whether an exception occurs or not. So the purpose of the finally suite is to perform cleanup operations such as closing files or other resources. Any code that is written in the finally suite will always execute, even if the try suite raises an exception. This is an example where a file is initialized to be none, and then in the try block, the file is open, so there's a file object that's assigned to this file variable. If something happens here, for example, and then an exception is raised, a handler for the IO error is executed. In that case, the file close will be skipped. However, I have a finally clause here, which check whether that file is none or not. If it's not none, that means a file has been opened and the file variable is referencing a file. In that case, I need to do some cleanup here to close the file. So basically, this finally suite will be executed no matter what. If there's an exception, it will be executed. If there's no exception, it will be executed as well. So this will guarantee that the file, which is a connection between the program to a file or a resource, will be properly handled, will be closed, so that any data will not be lost. What if an exception is not handled? Unless exception is handled, it will cause the program to halt. There are two possible ways for a thrown exception go unhandled. The first possibility is for the try except statement to contain no except clauses, specifying an exception of the right type. The second possibility is for the exception to be raised from outside a try suite. In either cases, the exception will cause the program to halt. And we have looked at some examples of IO error, division by zero error, value error, those type of exceptions. There are many more type of exceptions can be raised. And you can check this Python documentation to find more information about those exceptions. So why do we want to handle the exceptions? First of all, we do not want the program to halt all of a sudden. So it's possible that the exception that's happening will not affect the final output. In that case, we don't want the program just to stop. We want it to continue executing the rest of the program, although there's an exception in the middle. So we can basically just print out some error message and put that in the log so that programmer will be able to examine those messages to see what's wrong and what could be possibly causing errors in the code. However, those errors are not very critical. They do not affect the final output. So we want the program to continue running. Another reason we want to handle exceptions is that even if the program or the error is critical, we have to stop the program. We do not want to stop the program all of a sudden. We want to do this gracefully. We want to handle some closing or some resources that are still connecting to the program. For example, we want to close the files. We want to close the database exceptions. All these can be handled in either the error handling statements or in the finally suite. We can close database connection or close files or do some other cleanups to clean up the resources before we actually exit the program. So those are the main reasons we want to handle exceptions in our program.